Hello all. So today is the first session. So I hope let's everyone turn on their videos. So for 15 minutes or so, we will just have a introductions, and after that we will proceed with the questions. So today I'm going to deal with very important problem, unit hydrographs, and as well as a open channel flow, more specifically critical flow and other things. So I have taken a few questions from Gate 2022. So I'll solve those questions in front while discussing. So anyway, like if you guys have any questions, you can stop me anywhere in between. So let me give introduction about myself. So my name is yeah. Okay. So my name is kannegantib Kumar. I'm a PhD student in Indian Institute of Science, Bangalore. So my area of specialization is floods and flood forecasting, other things. So I joined for a PhD in 2019. So after that, I got selected for the Prime Minister Research Fellowship in 2020 through lateral entry scheme. So before that, I worked as a research fellow in Interdisciplinary Center for Water Research in IIC itself. So that is between 2018 to 2019. So before that, I did my masters in IIT Guwahati. So in I must say that like MTech is actually gives us more idea what we should become and whether we should take academic path as a career or should we go for industry and other things. So especially my MTech thesis like has motivated me a lot to pursue career in research and academia. So, let's come to the point. Gate 2015. I gave my gate in 2015. So it was the first online exam. So before 2015, like 2014 and all, like it was a paper. Like I can go to the exam center, they'll give the paper and I can write. But 2015 was the first time they ever started with this online exam, and we faced a lot of difficulty. And that time we don't have a good facilities to for coaching also. I prepared myself and I somehow got a good score and I got the seat in IIT Guwahati. So yeah, that is my story. Before and I did my BTech from Andhra Pradesh. So basically I'm from Andhra Pradesh. So yeah. So let's quickly introduce ourselves. All of you can just mention your name, full name, and your area, what you are whether you are studying or working, and when you're is it the first time you are attempting for the gate, or how many times you appeared in the gate before, and like that we can introduce ourselves. So I'll call the names. Just turn on your radio if possible and just say a few words. Maybe I'll start with Nikesh Sharma. Nikesh Sharma, are you there?
Yes, sir. I'm.
Yeah. So just briefly introduce about yourself, like your full name and other things.
Sir, I will be unable to on my video now.
Okay, no issue. You can just mention what is your name and where are you from and other things.
Okay, sir. Sir, my name is Nikesh Sharma and I am from West Bengal.
Hmm.
Sir, I have did my MTech in structural engineering from NIT Durgapur this year only.
Okay.
And sir, I have already appeared in GATE for two times in
Two times.
2020 and 2020.
Okay.
And this time, sir, I want to give GATE because I want to get a job in PSUs.
Yes. Yes. Okay, that's good. Yeah, definitely these sessions will help you in that. And see, in these sessions, we not only solve the questions, even we'll provide a career guidance also. Suppose if you have any general question about the companies, about the PUCs, or other things also, even PhD opportunity also, we are here to help you.
Okay, sir.
Thank you. So, Nandan, are you there?
Yes, sir.
Yeah, just briefly mention, tell about yourself.
Sir, I am Harnandan from Andhra Pradesh, sir.
Okay,
I recently studied a BTech final year, sir, in RVR and JC College, which
okay.
affiliated to Acharya Nagar University.
Hmm.
The GATE exam is used for I need to join Nickmore colleges, sir.
Nikmar.
Yes, sir.
Okay, okay. So,
That's the only that's only possible, sir. Right.
mm-hmm. Okay. So you attempted GATE before, or this is your first attempt?
Last year I have written, sir.
You have written. Okay,
Yes,
good.
sir.
Yep.
I just scored 21, sir, but cutoff is 26 and all.
Okay, no issue. Yeah.
That's it, sir.
Thank you.
Thank you, sir.
Vikash Kumar.
My name is Vikas Kumar sir. I
Hmm.
have recently completed my BTech Rashtravi Ramdhara Singh Dinkar College of Engineering. It is affiliated Arjavad Knowledge University, Patna,
Hmm.
Bihar. I come from Bihar sir. I have two times appeared in GATE but not qualified in GATE.
Okay, no, no issue, Vikash. This time, like we are here to help you out. So we will explain like all the problems in a very simpler manner, like how you can solve those tough questions in a very simple steps. That we will ensure in these sessions. So yeah, thank you, Vikas. So Aditya.
Thank you sir.
Good evening, sir. Myself Aditya Badi. I'm from Karnataka.
Hmm.
I am pursuing final year BE, sir, in civil engineering. I have attempted. This is my second attempt, sir. Applying it. Yes. I want to join MTech or POC. Sorry, I mean I should join MTech, sir, by pursuing it.
Okay, Aditya. Yeah, thank you. Ajay. Ajay, are you
Yes,
there?
sir.
Yeah.
Yeah. Sir, my name is Ajay Naravde. I am from Pune,
Hmm.
Maharashtra.
Hmm.
I have completed my BE this year from Ajinkya D.Y. Patil, Pune,
Hmm.
and I have appeared one time GATE in 2022, and I have to do MTech in structures.
Structures. Good. So, are you targeting any IITs?
Sir, IIT Bombay and
Sort of.
Roorkee.
Yeah, good choice. Thank you. Yeah, Amit.
Good evening, sir.
Good evening.
Myself Amit Kumar Mahadevande from Solapur.
Hmm.
I pursued my BE in Civil Engineering from Walchand Institute of Technology, Solapur.
Hmm.
I have appeared GATE one time, sir.
Hmm.
I wanted to do my career in PSU, sir.
Good. So, so you already attempted one, like
Yes,
one
sir.
time. So, how, were you able to? Were you close to the PSU selections, or you're very far?
No, sir. No, sir.
Okay, no
I am
issue.
not qualified.
No issue. I hope these sessions will help you in that. So yeah,
Yes, sir. Yes.
thank you. Mohit Chaudhary.
Good evening, sir.
Yeah, good evening, Mohit.
Sir, myself Mohit Kumar, and I am pursuing my BTech
Hmm.
from State Institute, and I am from Haryana.
Okay,
And sir, I have completed my 2 years of engineering.
2 years of engineering. Good. So, so you have 2 more years to like you can you able to write gate in third year? No, no. After you
Yes, sir.
complete, huh?
Sir, I am thinking on this.
Okay, okay, Mohit. Thank you.
Thank you.
Tanisya, PA.
Hello, sir.
Can
I'm
you speak up a
Tanshia.
little bit louder? We're unable to hear you.
Hello, sir. Can you hear? Hello? Hello?
Still not audible. Tanisya.
Hello?
Yes, please continue.
Sir, I'm from Kerala. I have attempted GATE in the previous year.
Hmm.
So this would be my second attempt.
Hmm.
I'm doing. I want to prepare and qualify for GATE in order to
So you did you
for doing
completed
my
your
MTech.
bachelor's or master's?
I have completed my bachelor's, and I intend to do the master's
MTech.
in in CFD. So yeah.
Okay, okay, Tansya, don't worry. These sessions will really help you in that. So I've seen like most of you attempted GATE. one or more times. But still, these sessions will give a different perspective, like how you can solve these questions in a very simpler manner. So in these sessions, we not only solve the questions, and even we'll give the inferences, like why this step and why the what are the steps to be followed while solving, and why these steps, and what are the reasons also. All these things we will explain very detailed. So in all these sessions, I deal with hydrology, fluid mechanics, and open channel problems. So in today's session, we will solve three questions from Gate 2022 session one. So most of you might have seen those questions. So when I present this question, I'll give you 1 minute. So if anybody has an idea how to solve this question, you can openly say and we can discuss. So these sessions are not like, these sessions should be interactive sessions. Means that you can stop me wherever you want and we can openly discuss. Okay. So before starting the session, anybody have any doubts, like uh, what you are expecting from this session, like what are the other things need to be discussed? Like, just I'll give 1 minute. So anybody have any queries, you can just ask me before starting the presentation. Yeah, I gave I attempted, like I've given this gate exam for twice. Once in 2015, another in 2018. So both the times I did not took a coaching. So I did a self preparation only. So 2015 I have written in sake of MTech. In 2018 I have written in sake of job and all. But unfortunately I could not got high marks. I was just near to the cutoffs. So, but with that same gate score and as well as my MTech degree, I got a PhD position in IISc. So that is a one option. So even with even if you have a good valid gate score, even you can pursue you can get a PhD admission in any IIT or NITs, and that is one good option. So let me tell you about a PMRF, this particular fellowship I am associated with that. So this particular PMRF fellowship will be given to 1,000 scholars across the India. So this is very prestigious scholarship, and under this scholarship, the Prime Minister's office will pay you 70,000 per month as a stipend, and as well as like some contingency amount for your all the laptops and other things. So if anybody has wanted to do a PhD and wanted to get qualified for a PMRF, I'm here to help you out. But definitely this is not only the money, but it gives you very much privilege for all the resource, like to access all the resources and other things. So under the PMRF scheme, I need to fulfill some TA requirements. So for the TA requirements, I have selected this gate portal to help the students out. So that is my intention here. Okay, let's start the session. So I'll present one the slides. So in this slides contains three questions from Gate 2022 session. So we will solve now. So can anybody respond whether they can able to see my screen?
Yes, sir.
Uh,
Yes, sir.
uh, Hello.
Yes, sir, visible.
Yeah. Yeah, this is a session one. So I already mentioned my name is kannegantib. I'm a PhD scholar in Institute of Science. So I work on a flats and flat forecasting other things. So in due course of time, I'll give a brief outline about my research also. So let's get into the business. So for this today's session, I have taken this first question from gate like question number 56 of Gate 2022 session 1. So I hope many of you have seen this question. I'll give you just 1 minute. So anybody can just mention whether they have seen this question. Hello.
Yes, sir.
So, can you guess this? Like any of you have seen this question?
No, sir.
Okay, let me read this question. This question is as follows: a 2-hour duration storm event, 2-hour duration storm event with a uniform excess rainfall of 3 centimeter occurred on a watershed. The ordinates of streamflow hydrograph resulting from this event are given in the table. So please note down, this is 2-hour duration storm event and has a rainfall excess of 3 centimeter, and this particular event resulted the stream flow hydrograph of these ordinates. So the question is that consider constant base flow of 10 meter cube per second and calculate the peak flow ordinate in meter cube per second of 1 hour unit hydrograph. Please note down, it is they asked to calculate 1 hour unit hydrograph. So in the question they have given 2 hour storm event and corresponding all the hydrographs, but they have asked you calculate the 1 hour unit hydrograph. And this question is for 2 marks. So when this question is for 2 marks, so at least we need to do some computations to solve this question. So before proceeding further, I just wanted to ask you guys, like anybody has an idea how we can solve this question? Anybody willing voluntarily, you can just respond. It need not to be exact, like you can respond. So a 2 hour duration storm event with a uniform excess rainfall of 3 centimeter on a watershed. The ordinates of stream flow hydrograph resulting from this event are given below. So the ordinates of stream flow hydrograph as given, and additionally they have mentioned that a constant base flow is consider, like we need to consider a constant base flow. So it has asked to calculate the peak flow ordinate in meter cube per second for 1 hour unit hydrograph. Okay, since nobody responded, let me explain briefly and graphically. So let's start with that. What they have given to us, let me draw. So this is a stream flow hydrograph. So this has given to us. So ordinates, all these ordinates they have given, like that all these ordinates are given. So from this they have asked to calculate 1 hour unit hydrograph. So to calculate this 1 hour unit hydrograph, we have to follow some steps. So this question we will solve by using S-curve method. So I'll tell you how we can solve graphically first. I'll give the intention what we are doing in this process. So this is a stream flow hydrograph. From this stream flow hydrograph, we need to detect the base flow. So suppose let's say assume this is a constant base flow they have given 10 meter cube per second. So now by detecting the base flow from the stream flow hydrograph, we will get direct runoff hydrograph. Hmm, 2 hour duration. Okay. So as we know, this direct runoff hydrograph resulted from the excess rainfall of 3 centimeter. So to get a unit hydrograph of 2 hours, what we need to do is that we need to divide this direct runoff hydrograph with a 3 centimeter. This is 2-hour unit hydrograph. So this will be the first step. So they have given the streamflow hydrograph. From this, we need to calculate the 2-hour unit hydrograph. From the 2-hour unit hydrograph, we need to generate the S hydrograph. So all these are D-hour unit hydrograph. In this case, 2-hour unit hydrographs. So I'll tell you what is S hydrograph and other things in due course of time. Just see what we are doing here. So this is 2-hour S curve. So this is 2-hour S curve. From this, what we will do is that we will lag this S curve by 1 hour. No, nothing but T hours. Let's say this is A, this is B. From there, we will get 1 DRH of T hour with the intensity of T by D. So this is direct runoff hydrograph. From this, we can easily calculate the 1-hour unit hydrograph by dividing with the T by D. So this is the overall graphical procedure. So, but let's see stepwise how we can solve. So, am I clear? Like at least have you guys have followed a little? Please, anybody respond? Like
Yes, sir, clear.
yeah. So this is a like step. Like this is the way we'll go. So for in this way we'll follow. So stepwise I'll show the things. So yeah. So I mentioned step one. So we need to construct 2-hour unit hydrograph from a streamflow hydrograph. On the right side of this slide, can you see this graph picture? So this picture is of streamflow measurement at the text source. So this I have taken from NT Chow book. This textbook is for advanced hydrology. So this particular graph shows the time variated discharge at a Millie Creek station. So you can see there is peaks on. So these peaks may resulted from some extreme rainfall event. So from this like stream flow, if we remove the base flow, we will get direct runoff hydrograph for that particular events. So essentially we do the same only here. So these are the ordinates. They have this is column 1 and 2 as given in the question. So for at the 0th hour, we have a 10 meter cube per second discharge. At 1 hour, we have a 16 meter cube per second discharge. At second hour, we have a 34 meter cube per second discharge. Similarly, at the 7th hour, we have a 10 meter cube per second discharge. So now let's deduct the base flow to get the direct runoff hydrograph. See this base flow, why we are deducting the base flow? Because this base flow is is not from the current event. It may be contributed by from the groundwater. It may be from the previous event. So our intention is to calculate the unit hydrograph for this excess rainfall amount. So because of that, we will remove the base flow from this thing. So by removing the base flow, so 10 minus 10, will be 0. So 16 minus 10 will be 6. 16 minus 10 will be 6. 34 minus 10 will be 24. Similarly, all other steps. So here you can see 25 minus 10 will be 15, 16 minus 10 will be 6, 10 minus 10 is 6. So please note down, in the direct run of hydrograph, the first ordinate and the last ordinate will be 0 only. And it will even continue for the unit hydrograph also. Even in the unit hydrograph, first ordinate and last ordinates must be 0. Okay, please note down, if these ordinates are not 0, then you might have made some mistake. Please check that. Okay, so column 4, so here I have written the formula, so how we got this. So column 4 will be column 2 minus column 3. So what is the column 2? It is a stream flow is a column 2 and the base flow is a column 3. So by deducting these elements element wise we'll get these values. So now to get a 2-hour unit hydrograph, we need to divide the column 4 with a 3 centimeter, because this is a direct run of hydrograph which resulted from the 3 centimeter rainfall excess. I hope all of you know what is the definition of unit hydrograph. Unit hydrograph, unit hydrograph is an hydrograph which resulted from the uniform rainfall intensity over an entire catchment. Suppose let's say this is a d hour duration, and it has 1 by d hour uniform intensity and has excess rainfall of, please pardon me if my rating is very bad, 1 centimeter. So this particular unit hydrograph resulted from the excess rainfall of 1 centimeter with a uniform intensity of 1 by d hour. So to make it that 1 centimeter excess rainfall, we need to divide this column 4 with a 3 centimeter. So 6 by 3 will be 6 by 3 will be 2, 24 by 3 will be 8, 30 by 3 will be 10.
So what is that 1 by D?
1 by
1 by D, sir?
1 by 3, not
1 by
D.
D. So
So
1 by
this
D you have
one,
written uniform
yeah.
intensity
So this will be uniform intensity.
of the rainfall.
Yes, of the rainfall. This is a definition of uh, unit hydrograph.
Okay, sir.
Yeah. For suppose similarly, if you go for the T hour unit hydrograph, then it will have a 1 by T hour uniform intensity. Similarly, that. Okay. So this is a step 1. So in the step 1, we have calculated the 2-hour unit hydrograph. So what is the step 2? Step 2 is to generate the S curve. So before generating the S curve, let me mention what is S curve. So S curve, also known as SO hydrograph, it is a hydrograph produced by, please note down, continuous effective rainfall, nothing but excess rainfall, continuous excess rainfall at a constant rate, maybe 1 by t hour or 1 by d hour, like that. Okay, for a infinite period. So that is a one definition. Another and how we can get this S curve? So it is a curve obtained by summation of infinite series of d hour unit hydrographs spaced at dh apart. So here we can see how it can be generated. I have shown you here. Yeah, here I have shown you. This S curve can be generated by, suppose this is a d hour unit hydrograph. You lag another d hour unit hydrograph and some. Similarly, you continue this process for infinite period. Here you can see for infinite period. Then you will attain to the constant discharge. So these are all like mathematical procedure to get a different duration hydrographs. So this is not possible in a real time situation. So these are the mathematical techniques to generate different duration hydrographs from the known hydrograph. Okay. So if you see this particular ordinate, this will be like u1 plus u2 plus u3. Like similarly, infinite. How many unit of we lag? In that way, we'll calculate. So let's see how we can construct here. So from the previous step, we have generated the 2-hour unit graph. So please note down this column number. So in the previous slide we ended with the column 5. I'm continuing with the same column 5. So I have taken the same value. So 0th hour is 0, first hour is 2, second hour is 8. Like that I have taken the values directly. So see this column number 7. So what is the note? Please observe this point. S curve obtained by summation of infinite series of d-hour unit graph spaced at dh apart. So in this case, let's say this is, let's say, 2-hour unit graph we already got from the previous step. Let's say I have lagged this unit graph 2 hour and perform this sum. So let's say this is 1, 2, 3, 4. Okay. So correspond, this will have 1, this will have another value, this will have another value, like that this will have na. So if you observe between 0 to 2, whatever the values are there, it will directly appear in the S curve. But from second, these values will get sum up. Can you note it down? So please observe, this is a critical point here. In this question, they have given ordinates at 1 hour interval, but the unit graph what we have is for 2 hour unit graph. This is a where we all make a mistakes. So many people, what they will do is that they'll simply lag these 2 times and add all the points. That is not correct. Please note down. So I'll critically observe. So what I'll do is that I'll take these first 2 ordinates, directly put it in column 7. So now these 2 ordinates I'll shift it together. I'll shift it direct together and place it here in column number 6. This column is nothing called as S curve addition. So now sum these two and place here. 8 plus 0 8, 10 plus 2 is 12. Now you take these two together and place it here. So now it will be 7 plus 8 15 and 5 plus 12 17. And again you take these two and place it together here. And it will be 2 plus 15 is 17 and 0 plus. So you continue this process until you reach the constant discharge. If you see all these like 17 are constant discharge. In this way you will generate the S curve. So I'll pause here. If anybody have a doubts, I'll clarify here. I hope I'm clear. Okay, let me move forward. So this is a step 2. Now this is a final step. So now we have the S curve, and from S curve how we can generate the T hour unit graph. So that is the same procedure I have demonstrated earlier. So consider two D hour S curves A and B. Here in this case 2 hour means 2 hour A and B displaced by T hour. In our case we need 1 hour unit graph, so it will be T will be 1. So if the ordinates of B, so consider 2 hour S curves A and B displaced by T hour. So you look at this figure, right side figure. This figure I have taken from Subramanya book. So consider 2 S curves A and B. So now lag these two curve by a T hour. So now you have lagged these two, and these two curves have a constant intensity of 1 by d centimeter per hour. Okay, and observe this thing, and this is T hour and has excess rainfall of 1 centimeter. Okay, now if the ordinates of B are subtracted from that of A, the resulting curve is a direct runoff hydrograph produced by a rainfall excess of duration TH with a magnitude of 1 by d into t centimeter. So suppose if we deduct this ordinates at this point and at this point, and this SA difference of SA minus SB is nothing but a DRH of excess rainfall of T by D centimeters. So this is a statement. So now from this DRH we need to calculate the here T is 1 hour in our case. So from this DRH we need to calculate the 1 hour unit graph. So how you will get, and we will simply divide this DRH with the T by D excess rainfall depth. So we will get the T hour unit graph. Okay, this is the procedure we can see. So observe the column numbers again. So I have in the previous step I have stopped at column number 7. So I have start with the same column number 7. So time same 0, 1, 2, 3, 4, 5, 7, 6. 7. So here I have added extra 2 columns because here we are lagging this curve by curve now. So as a safer side I have added, but though you added, but this ordinance will be 0, 0 only. So there is no issue. So this is S curve we obtained in the previous step. So 0, 2, 8, 12, 15, 17 and all. So now lag this S curve by 1 hour because we have asked to calculate what is a peak coordinate of 1 hour unit hydrograph. So now for that we have been lagged by 1 hour. Suppose if we ask peak coordinate of 3 hour, then we will lag 3. If we ask 2 hour, then we'll do the same similar manner. So we have lagged by 1 hour. So now this ordinance will go here. So now what we will do, we will deduct column number 7. So we will deduct column number 8 from the column number 7. So 0 minus 0, 0 minus something is like dash is 0 only. 2 minus 0, 2. 8 minus 2 is 6. 12 minus 8, 4. Similarly other things. Okay. So this particular is the DRH of 0.5 centimeter excess rainfall. So now we need to calculate the 1 hour unit graph. So how you will get the 1 hour unit graph? So this is a column number 9. Sorry, this is my mistake. This is a column number 9. So this is column number 10. So divide the column number 9 with the 0.5 centimeter. So by doing that, so it will be like 0.5. We will get the ordinates. So if you observe, what is the peak coordinate here? 12. So this they have asked to calculate. So this is the overall summary. So first you will calculate the stream flow. First you will calculate the direct runoff hydrograph from the stream flow by detecting the base flow. From the direct runoff hydrograph, you will get the 2 hour unit hydrograph by dividing the excess rainfall depth. From this you will get the S curve, and you will lag S curve by T hour, nothing but 1 hour here. So and from that you will get a DRH of 0.5 centimeter of 1 hour duration. Please note, observe carefully, like when I say 1 hour, 2 hour, it has to be proper. Then only we won't make any mistakes. From the DRH of 0.5 centimeter excess rainfall of 1 hour duration, we will get the 1 hour unit hydrograph by dividing this column number 9 by 0.9. So this is the overall step. So I'll tell you the shortcut. This is a very long procedure and it is worth for 2 marks. It worth for 2 marks. But I'll tell you the shortcut also, how you can proceed. Let me see how many are there. So yeah, before proceeding, like I'll before telling this thing shortcut, I just wanted to understand how many of you understood the question. I know this is a very long procedure, but it is worth to know, like because you can expect the question from Hydrograph every year, whether be it a 1 mark question or be it a 2 marks question. Every year in all the gate papers, you can expect at least one question from the Hydrographs. So it is necessary to know the detailed procedure. Okay. Yeah. So anybody wants to add anything here? Okay. Let me tell you this shortcut. So if you observe here, what they have asked, they have given 2 hour storm event, and they have given the 2 hour stream flow hydrograph, but they have asked you to calculate the peak flow ordinate of 1 hour in hydrograph. See, if you observe the column number 5, this is a 2 hour unit hydrograph which we have calculated by deducting the stream flow. And observe this carefully. You subtract ordinates of 2 hour unit hydrograph only. I mean, hmm, I mean 0 minus 2. How much is the difference? 2. 2 minus 8. How much is the difference? 6. 10 minus 8. How much is the difference? These things. Similarly, other steps. So observe what is the maximum difference you got here? 6. And what they have given the 2 hour unit hydrograph, but they have asked you to calculate the 1 hour unit hydrograph, isn't it? So what you can do? So how you can do is that you can divide this 6 by 1 by 2 equal to 12. This works for the peak flow ordinate. This works for the peak flow ordinate. This will be shortcut. So what you will do? Sorry. You will look at the difference of the ordinates and pick the maximum difference and divide with this thing. Suppose here is 6, here is a 6, and this is they have asked t by d directly. So 6 by t by d you will get. Suppose here they have asked you to calculate 4, then what will be 4 by 2? So answer will be 3 meter cube per second. This will be peak flow ordinate. Understood? I hope it is clear. I hope I'm clear.
Yes, sir, it was clear.
Yeah. So did you understood the shortcuts? It will work for the peak flows.
Yes, sir, it was interesting, sir.
Yeah. So we just look at the difference between the ordinates, pick the maximum one, and
Yes, sir.
divide with that 1 by 2 or 4 by 2, whatever it is. Okay.
Yes, sir, it is nice, sir.
Yeah. Thank you. Let's move to the next question quickly. So we are running short of time. So now we'll solve another question from open channel flow. Yeah. So this question is 58. Question number 58 from Gate 2022 Session 1. So in this question, they have asked you to calculate the bed width. So let me read the question carefully. So they have given depth of let me read the question. So depth of water flow. So depth of water flow in a 3 meter wide rectangular channel is 2 meters. The channel carries a discharge of 12 meter cube per second. Take acceleration due to gravity as a 9.8 meter per second square. This is the given data. Now the question is that the bed width in meter at contraction, which is just cause the critical flow, is how much dash dash without changing the upstream water level. So let me give you what they have asked in this question. Imagine this is a channel. This is a channel in a plan view. Let me draw another thing. So this is a sectional view. So how much is the width? They have mentioned 3 meters, and the current depth of flow is 2 meters. Okay. So let's say this. Let me take this is a section 1 and let me mark it as a critical section C, and this cross section is at section 1. Okay, so now what they have done is that they wanted to reduce the bed width. Let's say this is B minimum. Okay, so now they have asked you to calculate what is this value without changing the upstream water level, and it means that the channel should carry the same discharge Q, but it should have a minimum width. So these kind of actions we will perform when we want to reduce the cost of the construction and other things. At we need to solve the purpose also, because like if there is a any cropland any downstream of this channel, we should serve this same amount of discharge for the crops. But yet suppose if we want to reduce any economy and other things, we will perform these kind of actions. So let's see how we can. Let me give you the theory part here. So the critical state of flow has defined as the condition for which Froude's number is equal to unity. I think all of you know what is a Froude number. Froude number will be V upon G rho Y, nothing but inertia force by gravitational force. So this I have written for the rectangular channel. Rectangular channel. So more general formula will be Fr square equal to Q square T by G into A cube. I hope I am correct. This is a more general formula, but for the rectangle we can simplify as V by root of Gy. So in this case, Froude number will be 1 for the critical flow. A more common definition is that the state of flow at which the specific energy is minimum for a given discharge. So what is specific energy? Specific energy is nothing but energy per kg of water at any section of channel measured with respect to channel bottom. I think all of you know, it's like we have this potential energy, kinetic energy, pressure energy, and other things. So here in open channel case, this we called as a specific energy, and here we neglect the potential energy as 0 because we are calculating the specific energy with respect to the channel bottom. So Z will be 0 only. So and this particular will be velocity kinematic head, and this is a pressure head. This is pressure head. So at critical state of flow, the specific energy is minimum or nothing but dE by dy equal to 0. So by solving this dE by dy equal to 0, we will get some relation between the EC equal to depth of flow. So all these derivations are out of scope now. Just remember what is the critical state of flow and what happens at because this particular point they may ask in one more question. So at a critical state of flow, the specific energy is minimum. And this definition also you should remember. Sometimes they may ask for one more question. So the critical flow is nothing but a state of flow at which the specific energy is minimum for the given discharge. Okay. So imagine let B minimum is the minimum width of channel for which flow is possible without any change in upstream flow condition. Because in the question they have asked, we should calculate the width of channel without changing the upstream flow condition. So we should keep this point in mind and we will calculate it. So how we can calculate the B minimum? So we have this formula. I have shown you already. This will be kinetic head and this is the pressure head E1. And so when B equal to B minimum, this C1 will become EC. That is nothing but specific energy will become critical minimum specific energy, critical energy. So the upstream depth of flow continues at y1 because we should not change the upstream depth, and the depth of flow at the downstream section will be critical depth corresponding to a specific energy of EC1 equal to E1. So by, like I already shown you, by solving this particular equation, we will get the relation between the EC and YC. So it will be 3 by 2, not 1 by 2. Sorry, EC will be equal to 3 by 2 of YC. So this derivation you can find in any textbook, but this is not this is out of scope now. So just remember this formula: E is equal to 3 by 2 of Y. So we will get this particular equation, and from there we can reshuffle the terms, and we can get a B minimum as square root of Q square by G into 2 by 3 of EC whole cube. Remember this formula and note down this formula. This formula may be useful to you. Here this 2 by 3 EC is a Y. Okay. Yeah. So now solve the questions. So depth of water flowing in a 3-meter wide rectangular channel is 2 meter. So here width is 3 meter at section 1 and depth is 2 meter. The channel carries a discharge of 12 meter cube per second, and the G is 9.8 meter per second. So this is acceleration due to gravity. So they have asked you to calculate what is a bed width at a contraction which just causes the critical flow, which means that E is EC, just a critical flow. So let first note down what are the given data. Given the Y1 is 2 meters, B1 is 3 meters, discharge is 12 meter per second, acceleration due to gravity is 9 meter per second square. So step 1. What is the step 1? You need to calculate the specific energy at upstream section. E1 equal to Y1 plus Q square by 2 into G into A square. So you will write 2 meter depth plus 12 square divided by 2 into 9.8 into, here I know area of rectangle will be B into H na. So here it is like depth, we need to calculate only flow depth. So 3 into 2 whole square, it will be 2.204 meter square. So once you know the E1, so at when B equal to B minimum, E1 will become EC. So with this relation, with this condition, we will use the same. I have shown you this formula in a previous slide. So the bed width at a contraction B minimum when the flow is critical, E1 equal to EC. So by substituting the same all these formulas here, so 12 square equal to 144. So divided by 9.8 into 2 by 3 into 2.203 whole cube, we will get a 2.152. Here you see, this is also one mistake we make. They told round off to 2 decimals, but here I have shown you 2.152 meter square. So please note down, when they specifically mention 2 decimals or 3 decimals, you always mention those decimals. Suppose if you mention 2.1 meter, sometimes the correct range may be different. So sometimes the correct range may be 2.122, 2.15. Then you may be wrong. So please read this particular point carefully and answer accordingly. So yeah, so this is one question. We will just 1 minute we will take. This is a question number 20. This is one more question from GATE 2022 session 1 only. So here they have asked you to just take one mark like so let psi represent soil suction head and K represent hydraulic conductivity of the soil. If the soil moisture content theta increases, which of the following statement is true? You just need to identify. So soil suction head nothing but the pressure, and K represent the hydraulic conductivity of the soil. This is a property of the soil. So how these both are various with respect to the soil moisture content. Suppose imagine the soil moisture content is increasing. See, observe this x-axis. So 0 to 3, 5 and so on. When the soil moisture content is increasing, the hydraulic conductivity of the soil is increasing. Whereas this soil suction head is decreasing. So what is the correct answer here? That phi decreases and K increases. Option A. Okay. Yeah.